Good morning. Today we're going to be talking about expansion regions. If you've never heard of these, they are an option that you have in an activity diagram, and they originate from the UML specification. So what can you use expansion regions for? Really, they are good for essentially parsing out arrays. So anywhere where you may have an array that you would like to act on individual parts of, it may be worth considering using an expansion region to do that. That way you don't have to get in and do any fancy programming in order to actually parse out the specific parts of your array. So let's look at a block definition diagram here. In this example, what you see is this iterative expansion region execution block has a value property that's named collection of values, and it's typed as a string. It has a multiplicity of unlimited. But then if you notice, it actually comes with an array. And that array is essentially what is treated as a collection when this is instantiated. What we'll do is we'll feed this value into the expansion region. And notice in this case, the expansion region has the mode set to iterative. And there are three separate modes that you can set with an expansion region, that being iterative. And if you look, you can right click and go to parallel or stream. With an iterative expansion region, you can only have one execution that is performing functions on those parts of the array at a time, where if you have a parallel expansion region, you can actually perform concurrent or simultaneous functions on parts of those arrays, and you can have multiple inputs coming in. So you might have multiple collections that are showing up into that region where you have various arrays or various functions happening on those arrays at the same time. Now, with this stream selection that you can make, that essentially will be delivered as an entire array, even though it seems like it should parse that out and then stream that. The interesting thing is I have not been able to get Cameo Simulation Toolkit to actually perform a streaming expansion region function. So maybe you guys out there will have some ideas as to how you could actually use that stream. But a few things to note before we kick off some of these simulations are, notice this input here, that is considered an input expansion node. Notice it also has what looks like 4 inputs. That is actually simply the icon for that. It does not indicate that there are 4 of anything. It's supposed to indicate that there is a set of values that will be arriving at that input node. So in this example, what we'll do is we'll actually have this collection of values, which is an array, coming into this node. And then what's interesting here is we'll actually send these one at a time with this send signal action via a port and have them arrive in a different context, one value at a time. So that is one example of something that you could do with this. So let's go ahead and run this simulation and watch how this works. I'll run this from the context block. That way we'll instantiate both of these part properties. And now notice that we only have one of those values of the array arriving as the data with that message each time. Now you can send an entire array of values as an asynchronous message or asynchronous send signal action that will be received in its entirety. However, in this case, it's interesting because you could also parse that out one at a time and send that as partial data that you would then read in some other context. So that is an interesting use case for an iterative expansion region. There's another one that I'd like to flip over to, and the idea that I've gotten for this one actually came from a sample project that is in the Cameo install files. So if you look at the install files of Cameo and go to samples, there's a trade study pattern MD zip file, and if you open that up, there's a trade study block, and what it will actually allow you to do, let's look at that quickly. If you notice, this is an iterative expansion region. What it does is actually goes through a number of alternatives that you may have for a trade study, and then it picks the highest value of those, and then it'll actually output that, and you can output that to an instance table where you would then see which of those would be the winner. And in this case, that's what that could look like. So notice how we have instances of these different types of things where it actually evaluates those as an alternative iteratively, and it will output a winner. So this is done with instances. So I'd like to show you guys quickly how you could do something like that, or create a collection of instances that you could then iterate through and look at different values of. Let's look at how you could actually do something like that. So there's a block definition diagram here. Notice we have this block that'll be executing that expansion region, and the name of this block is iterative expansion region execution. But then notice we also have this association, and the association is essentially a reference property. And we have a block that I've named object, and it's from the perspective of this block, it is a reference property named object that's typed by object. So notice I've created 5 instances of that object block. And then what you can actually do is create another instance of a block that owns that. And then you can assign these instances as part of what is being called object, because we set the upper bound multiplicity to unlimited, meaning we can have multiples of those. So if you look at the specification for this instance, notice we have slots. And if you go to object, what you can do is create values, and it'll look for anything that's typed by that object block, or any instances that are typed by that object block that you could then add to this. So this now is being treated as a collection of objects. So what we'll do is essentially look at each of those one at a time. So we will run this instance specification that now has all of these objects set, which are essentially now treated as a collection. And then this will iteratively look at each of those. So down here, you'll see that we'll be printing out the names of those one at a time. So notice it's bringing in each one of those one at a time. And then, like that trait study pattern does, it actually then goes and looks at specific values of those objects and compares them to see which one of those is the highest. So this is a dumbed down example of really what is happening with that, which is it's iterating through that set of objects, or that collection of objects that is really just an instance specification. And then, so that is a neat use case for using an iterative expansion region. And then the other one that is fairly interesting as well is a parallel expansion region. So notice in this case, we might have a few different collections that we'd like to pull into this parallel expansion region, and then act on each of those, but only one position of the array at a time. What we could then do is pass those values to other functions that would be executing in parallel, and then we can update some other value property. And then there's something that's good to know about add structural feature value actions, and that's that there is one setting in these that is very important, and that's whether or not you'd like to update that with the latest value, which is replace all set to true, or if you'd like to have that set to false, which simply tacks on the latest value to the array. So let's run a simulation of this and watch what happens. Notice we're getting both of the collections, and then each one of these will have functions that are performed in parallel, and then we'll be outputting a single value to this value property that is named resulting collection. So notice we have this one value that is now 1012, but then when we get another value, it's then tacked on as an additional value in that array, because the add structural feature value is not set to is replace all. So that is very important to pay attention to if you're using add structural feature values, and that is whether or not you have that set to is replace all. So this essentially will keep going until this runs out of values in the array. Now, one question that may come up is, what if these arrays or these collections are different sizes? Well, if you look at the UML specification, it talks about whichever one has the smallest size will be used as the amount of values that this will iterate through, and I would assume all of the values that are left over will simply be ignored if you had some collection that were higher than that smallest size of the other collection. So that's something to pay attention to as well, is the sizes of the collections that you're pulling into these. So one other example of how you could use something like this is found in the UML specification. And if you look through there for expansion regions, somewhere around page 527, what you'll find is there is an example of a parallel expansion region that is performing a fast Fourier transform. So that is something that would be interesting to attempt to do in Cameo, would be some type of a transform such as that. I know a lot of people typically are not aware that you can do something like that in Cameo, thinking that it is more appropriate to do that in MATLAB, but that is something that you could absolutely do in Cameo and pass those different collections or those different complex numbers to opaque actions. So these could be opaque actions in your expansion region, and then pass outputs that would have collections that could then be combined into other arrays of complex numbers. So there are a few other examples in here, but the one I haven't been able to find are any good examples of the streaming. So as you know, you can perform streaming functions using a call behavior action with that input simply set to 0 to unlimited multiplicity. So there are ways to do streaming functions, but I have not been able to successfully perform a streaming expansion region. Not to say that you can't do that, but I'd love to see if you guys have any great examples out there of something like that. I hope this has been helpful. If your project is in need of any assistance with MBSE, please feel free to reach out to STC and we'd be happy to help.